Alright, let's go. Number 10. The WOW signal's calculated silence. On August 15, 1977, astronomer Jerry Ammon was reviewing data from Ohio State University's Big Ear Radio Telescope when he saw something that made him grab a red pen and scribble a single word in the margin. Wow! The signal lasted exactly 72 seconds, the maximum duration Big Ear could observe any point in the sky as Earth's rotation carried the telescope's field of view across the cosmos. What made this transmission extraordinary wasn't just its power, 30 times stronger than the background noise of space, but its precision. The signal centered on 1420 megahertz, the exact frequency scientists had theorized would be used for interstellar communication. This frequency corresponds to the emission line of neutral hydrogen, the most abundant element in the universe, making it a logical choice for any civilization attempting to make contact across the vast distances between stars. The signal appeared to originate from the constellation Sagittarius, near the star group Chi Sagittarii. Its characteristics bore all the hallmarks of an artificial transmission: narrow bandwidth, specific frequency, and intensity pattern consistent with a broadcast from beyond our solar system. Most importantly, it matched precisely what researchers had predicted an extraterrestrial message would look like. Despite 47 years of searching with increasingly sophisticated equipment, the WOW signal has never been detected again. Scientists have ruled out terrestrial sources, satellites, and known celestial phenomena. In 2017, a researcher proposed a passing comet might have caused it, but this theory was largely dismissed because comets don't emit strong radio signals at that specific frequency. What makes the WOW signal truly unsettling isn't its mysterious origin, it's the deliberate silence that followed. Some scientists now theorize this wasn't a greeting, but a test, an advanced civilization checking if we had reached the technological threshold to detect radio transmissions. The 72-second burst was sufficient to confirm our capability. The decades of silence that followed suggest they made a decision based on what they learned. Whatever conclusion they reached about humanity, it apparently didn't warrant further contact. Number 9. The Dyson Sphere candidates. In 2021, astronomers analyzing data from the VISTA variables in the Via Lactea survey discovered something that shouldn't exist. VVV-WIT 07, a star located approximately 25,000 light-years away near the center of our galaxy, had dimmed by 80% over several months before gradually returning to its normal brightness. This wasn't a brief flicker or a regular variation. It was a sustained, dramatic reduction in starlight that violated conventional astrophysics. To understand the scale of this dimming, consider that when a Jupiter-sized planet transits in front of a sun-like star, it blocks roughly 1% of the star's light. Even the largest known planets cause dips of only a few percent. An 80% reduction requires an object thousands of times larger than Jupiter, or a structure specifically designed to block starlight on a massive scale. What makes VVVWIT-07 particularly compelling is its pattern. Unlike Tabby's star's irregular, chaotic dips, this dimming followed a smooth curve, suggesting a single massive object in orbit. The timescale, spanning months, indicates something enormous moving through space between us and the star. Astronomers officially propose a giant disk of dust and debris, possibly from a planetary collision or disintegrating comet, temporarily obscured the star. But the characteristics match another explanation with unsettling precision. In 1960, physicist Freeman Dyson proposed that sufficiently advanced civilizations would eventually build megastructures around their stars to capture solar energy. A Dyson sphere or Dyson swarm, thousands of orbiting collectors working in coordination, would appear from a distance exactly as VVVWIT-07 appears, blocking massive amounts of starlight as the structure orbits or rotates. If this interpretation is correct, we're not observing a natural phenomenon. We're witnessing a civilization that has achieved what's known as Kardashev Type 2 status, capable of engineering on stellar scales, harvesting the total energy output of their sun. The structure would represent technology millions of years beyond our current capabilities, built by beings who view stars not as distant objects of wonder, but as batteries to be tapped. Somewhere in the darkness near the galactic center, something might be feeding. Number 8. The Dark Forest Hypothesis. In 1950, physicist Enrico Fermi sat down to lunch with colleagues at Los Alamos National Laboratory and posed a question that would haunt astronomy for decades. Where is everybody? His logic was inescapable. The Milky Way contains roughly 400 billion stars, many host planets. Given the galaxy's age of 13.6 billion years, even if intelligent life is rare, we should see evidence of thousands of civilizations. Yet when we scan the cosmos, we detect nothing but silence. This absence has spawned dozens of explanations, but one stands apart for its chilling implications. Chinese science fiction author Liu Cixin, drawing on game theory and evolutionary biology, proposed what he called the Dark Forest Hypothesis. The universe, he suggested, resembles a dark forest where every civilization is an armed hunter moving quietly through the trees. They remain silent not because they're alone, but because they know others are listening. The logic is ruthlessly simple. When you detect another civilization, you face what's known as the chain of suspicion. You don't know their intentions. You don't know if they perceive you as a threat. You don't know if they're wondering the same about you. Even if both civilizations desire peace, neither can be certain the other won't strike preemptively. The only guaranteed survival strategy is to eliminate potential threats before they become threats, or to remain invisible. This transforms the Fermi paradox from a mystery into a solution. The silence isn't empty. It's deliberate. Mature civilizations have learned that survival requires invisibility. They've detected our television broadcasts, our radar emissions, our deliberate messages beamed toward nearby stars. They've noted our location, assessed our technological level, and added us to their threat assessment databases. What makes the dark forest hypothesis particularly disturbing is its treatment of our own behavior. For 70 years, we've been broadcasting our presence with increasing power. We've sent detailed maps showing Earth's location. We've transmitted information about our biology, our culture, our capabilities. If the dark forest theory is correct, we haven't been reaching out with hope. We've been painting a target on our planet, loudly announcing our presence to predators we're too primitive to detect. The universe's silence might not be a mystery. It might be a warning we're too naive to understand. Number 7. The Oumuamua ancient wreckage theory. On October 19, 2017, astronomer Robert Wreckage discovered a faint object tumbling through the inner solar system at 87.7 kilometers per second. Named Oumuamua, Hawaiian for scout or messenger, it was immediately recognized as special. Its hyperbolic trajectory confirmed it came from interstellar space, making it the first object from beyond our solar system ever detected passing through our cosmic neighborhood. Then came the anomaly. As Oumuamua swung around the sun and began its journey back into the void, it accelerated slightly beyond what gravity alone could explain. The acceleration was small, roughly 5 times 10 to the negative 6 meters per second squared, but it was real and measurable. When comets accelerate, they do so through outgassing, ice vaporizing into jets of gas that push them forward. But Oumuamua showed no tail, no coma, no detectable emissions whatsoever. Harvard astronomer Avi Loeb performed calculations that sent ripples through the scientific community. If Oumuamua were a light sail, a thin reflective surface pushed by solar radiation, its dimensions would need to be less than a millimeter thick, but hundreds of meters across. These specifications match exactly the theoretical designs for interstellar probes proposed by aerospace engineers. Thin reflective sheets that accelerate by bouncing photons off their surfaces. What disturbs scientists more than the artificial hypothesis is the trajectory analysis. Oumuamua didn't arrive from any nearby star system. Researchers traced its path backward and found it came from the direction of the local standard of rest, the average motion of stars in our galactic neighborhood. This means it wasn't recently launched. It's been drifting through the galaxy for millions, possibly hundreds of millions of years. If Oumuamua was artificial, we didn't encounter an active probe making a deliberate visit. We found debris, ancient wreckage from a civilization that might have gone extinct, while Earth's most complex life was still single-celled organisms. Somewhere out there, beings built technology capable of crossing the distances between stars, then vanished into cosmic history, their machines still wandering the galaxy long after their creators turned to dust. Number 6. The Tabby's Star Century Scale Enigma. In 2015, astronomer Tabitha Boyajian and a team of citizen scientists discovered something unprecedented in data from NASA's Kepler Space Telescope. Star Keck 8462852, located approximately 1,470 light-years away in the constellation Cygnus, was dimming in ways that violated every model of stellar behavior. The dips weren't regular like planetary transits. They were chaotic, irregular, and enormous, with some events blocking up to 22% of the star's light. To understand how extraordinary this is, consider that when Jupiter, the largest planet in our solar system, passes in front of the Sun, it blocks roughly 1% of the light. Even a massive gas giant, many times Jupiter's size, couldn't cause a 22% dip. The scale suggested something far larger, or many objects working in coordination. Then came the deeper mystery. In 2016, astronomer Bradley Schaefer analyzed photographic plates from Harvard's collection, some dating back to the late 19th century. He discovered that Tabby's star had dimmed by approximately 16% over the past 100 years. This secular dimming rate is physically impossible for natural stellar evolution. Stars don't lose 16% of their brightness in a century without catastrophic events like supernova, which Tabby's star clearly hasn't experienced. The leading natural explanation involves dust, perhaps from a swarm of comets or the aftermath of a planetary collision. Evidence supports this. Observations in 2018 showed the dips affect blue light more than red light, consistent with small particles scattering shorter wavelengths. But dust fails to explain the century-scale dimming or why the star occasionally brightens beyond its baseline level, behavior that contradicts simple dust obscuration models. Penn State astronomer Jason Wright noted that the light curves match theoretical predictions for a Dyson swarm under construction, thousands of solar collectors being assembled in orbit around the star. If this interpretation is correct, we're not observing a natural phenomenon playing out. We're watching a construction project, witnessing a civilization working on a timescale of centuries to harness their star's total energy output. The most unsettling aspect isn't the possibility of artificial origin, it's the patience it implies. Beings planning and building across generations in ways that make our longest-term projects look like the impulsive actions of children. Number 5. The Proxima Centauri coincidence. On April 29, 2019, the Parkes Radio Telescope in Australia, operating as part of the Breakthrough Listen project, detected something that matched every characteristic scientists had predicted for an artificial signal. The transmission was narrowband, centered at 982.002 MHz, and showed a frequency drift pattern of approximately 0.1 Hz per second. This drift was consistent with a signal originating from the surface of a rotating planet, the Doppler shift caused by the transmitter's motion as the world turned. What made this detection particularly compelling was its source direction. The signal appeared to come from Proxima Centauri, the nearest star system to Earth at just 4.24 light-years away. More significantly, Proxima Centauri hosts at least 2 confirmed planets, including Proxima Centauri b, a world orbiting within the habitable zone, where liquid water could exist on its surface. The signal was detected during on-target observations of Proxima Centauri and appeared absent in off-target control observations, suggesting it originated from the star system's direction, rather than from terrestrial interference. It persisted over multiple hours of observation, demonstrating stability that seemed inconsistent with random radio noise or brief satellite glints. Breakthrough Listen's analysis, published in October 2021, ultimately concluded the signal was most likely radio frequency interference from human technology. The team identified similar characteristics in other candidates that were definitively terrestrial, yet they never identified the specific source of this particular signal. The exact origin remains officially unconfirmed, attributed to interference through process of elimination rather than definitive identification. What haunts researchers about this detection is the timing. Proxima Centauri b was confirmed to exist in August 2016, making global headlines as the nearest potentially habitable world to Earth. This signal was detected less than 3 years later. If something exists on or around Proxima Centauri b, they would have detected our intensified observation of their system, our telescopes and radio dishes suddenly focusing on their star with unprecedented attention. The signal's timing creates an uncomfortable possibility. Perhaps we're dismissing as noise the very thing we've been searching for, unable to distinguish genuine contact from the interference patterns of our own technology. Number 4. The fast radio burst clockwork signal. In 2012, astronomers detected FRB 121102, a burst of radio energy lasting just milliseconds, but releasing more power than the sun produces in an entire day. Unlike other fast radio bursts that appeared once and vanished, this one repeated. Over the following years, astronomers cataloged dozens of bursts from the same location, a dwarf galaxy approximately 3 billion light-years away. Then in 2020, researchers discovered something that defied natural explanation. The bursts weren't random. They followed a precise cycle, 90 days of activity during which multiple bursts could occur, followed by 67 days of complete silence. Then the pattern repeated with clockwork precision. The 157-day cycle has continued without deviation, a cosmic metronome ticking with mathematical regularity across billions of light-years. No known natural astrophysical process operates on this timescale with this precision. Magnetars, the leading natural explanation for fast radio bursts, are highly magnetized neutron stars that can produce powerful radio emissions. But magnetar activity is typically random or operates on much shorter periodicities measured in seconds or minutes, not months. Binary star systems can create periodic phenomena, but the timescales usually correspond to orbital periods measured in hours or days, and nothing in known physics explains a 157-day cycle. Black hole accretion disks, colliding neutron stars, and exotic plasma interactions all produce energy on the required scale, but none create periodic patterns spanning months with absolute consistency. The precision suggests either an artificial beacon operating on a predetermined schedule, or a natural phenomenon so exotic we have no theoretical framework to explain it. What makes FRB 121102 truly unsettling is the timeline. Located 3 billion light years away, the bursts we're detecting today were transmitted 3 billion years ago. At that time, Earth's most complex life consisted of single-celled organisms. Multicellular life wouldn't emerge for another billion years. If this is a signal, it was transmitted when our planet was a barren world of bacteria and algae, meaning whoever or whatever is sending it has been broadcasting with unwavering consistency for longer than complex life has existed on Earth. The question isn't just what creates such a signal, but what could maintain it across timescales that dwarf the entire history of biological complexity. Number 3. The Kardashev scale's hierarchy of gods. In 1964, Soviet astronomer Nikolai Kardashev proposed a method for classifying civilizations based on their energy consumption. A Type 1 civilization harnesses all available energy on their planet, approximately 10 to the 16th watts. Type 2 harnesses their entire star's output, roughly 10 to the 26th watts. Type 3 controls their entire galaxy, approximately 10 to the 36th watts. The scale provided a framework for understanding technological advancement and potential encounters with extraterrestrial intelligence. Humanity currently ranks at approximately 0.73 on this scale. We haven't achieved even Type 1 status. We extract energy from fossil fuels, nuclear reactions, and renewable sources, but we cannot yet capture hurricanes, orchestrate tectonic activity, or control our planet's total energy budget. Physicist Michio Kaku estimates we're perhaps 100 to 200 years from achieving Type 1, assuming we survive climate change, nuclear proliferation, and other existential risks inherent in our current technological adolescence. Reaching Type 2 requires capabilities that seem almost magical from our current perspective. A civilization would need to construct megastructures like Dyson spheres or Dyson swarms, billions of orbiting collectors that capture their star's total output. The engineering challenges are staggering, requiring the manipulation of planetary masses of material, construction projects spanning centuries or millennia, and coordination on scales we struggle to comprehend. Conservative projections suggest reaching Type 2 requires at least 1,000 to 10,000 years of sustained technological advancement without self-destruction. Type 3 civilizations exist on timescales and scales that make Type 2 seem primitive by comparison. They would view stars as we view light bulbs, galaxies as we view cities, capable of relocating solar systems, engineering on scales spanning hundreds of thousands of light years, existing across millions of years of continuous development. The terrifying implication of the Kardashev scale is what it means for potential contact. Any civilization we detect would almost certainly be Type 2 or beyond, placing them thousands to millions of years ahead of us technologically. The gap between us and them would dwarf the gap between us and ants. We wouldn't be meeting cosmic neighbors or potential equals. We would be encountering beings whose capabilities and motivations are as incomprehensible to us as quantum mechanics is to insects, gods whose purposes we couldn't fathom and whose actions we couldn't predict or prevent. Number 2, the Great Silence as universal graveyard. The Drake equation, formulated by astronomer Frank Drake in 1961, attempts to estimate the number of communicative civilizations in our galaxy, even using conservative parameters, plugging in the rate of star formation, the fraction of stars with planets, the number of habitable worlds per system, and the likelihood of life developing intelligence. The equation suggests thousands of detectable civilizations should exist within our galaxy alone. Yet, when we point our telescopes at the stars and listen with our most sensitive radio receivers, we detect nothing. The silence is so profound, so complete, that it has become its own field of study. This absence led statistician Stuart Armstrong to perform a chilling calculation. Given that the Milky Way is approximately 13.6 billion years old, and considering the exponential nature of technological growth, even a single spacefaring civilization expanding at a fraction of light speed could colonize the entire galaxy in roughly 50 million years. That's less than 1% of the galaxy's age, a cosmic eye blink. Yet we see no evidence of colonization, no Dyson spheres harvesting stars, no megastructures, no radio chatter, nothing. The complete absence of evidence suggests something systematic. Either intelligent life is far rarer than our equations predict, emerging perhaps only once per galaxy or less, or something prevents civilizations from reaching the spacefaring stage. The possibilities are equally disturbing. Perhaps intelligence is an evolutionary dead end, a trait that appears briefly before driving species to extinction through warfare, environmental collapse, or technological catastrophe. Perhaps there's a great filter, some challenge that all technological civilizations face and none successfully navigate. The galaxy might not be empty because life is rare. It might be empty because the universe is filled with ruins, dead worlds orbiting distant stars, the archaeological remains of thousands of civilizations that all reached our current level of technology and then vanished. The silence we interpret as absence might actually be the loudest message the universe can send, a warning written in the graves of everyone who came before us. Number 1, the transition point countdown. In 2023, Centauri. A team of astrobiologists analyzing humanity's technological trajectory identified what they termed the transition point, the moment when a civilization becomes electromagnetically visible to the rest of the universe. For humanity, this occurred around 1950, with the deployment of high-powered radar systems and television broadcasts. Our radio bubble has been expanding at light speed for 74 years, currently extending across a sphere approximately 148 light-years in diameter, encompassing thousands of star systems. The researchers then performed calculations that revealed a disturbing pattern. Every technological civilization must pass through this transition point, the brief window between developing electromagnetic communication and either achieving interstellar capability or facing extinction. They analyzed the typical lifespan of technologies, the rate of resource depletion, the mathematics of exponential growth, and the timescales required for developing sustainable interstellar technology. Their conclusion was stark. Most civilizations have approximately 100 to 200 years from their transition point to either succeed or fail. The threats are numerous and converging: climate instability from rapid industrialization, nuclear proliferation as energy demands increase, artificial intelligence emergence before adequate control frameworks exist, and the destabilization that comes from social systems evolving slower than technological capabilities. The window's narrow because the same technologies that make a civilization detectable also make it vulnerable to self-destruction. Humanity is currently 74 years past our transition point. If the model holds, we have somewhere between 26 and 126 years remaining to either develop the capability to become a true spacefaring species or join the Great Silence permanently. The Fermi paradox might not be mysterious at all. Perhaps the universe isn't filled with advanced civilizations because advancement itself is the filter. Perhaps thousands of species have reached exactly where we are now, detected the same cosmic silence we hear, and then added their own silence to it. The most advanced civilizations in the universe might not be the ones that built Dyson spheres or colonized galaxies. They might be the ones that never advanced at all, species that remained at pre-industrial levels, never developing the technologies that both enable detection and guarantee eventual collapse. The cruel mathematics suggests that becoming technologically sophisticated enough to ask if we're alone might be the same thing as becoming sophisticated enough to ensure we soon will be. If you want to see more videos like this, click the video on screen now and make sure to subscribe.